All right, everybody. This is going to be a review for the Unit 3 test, Part 1. So this will only be on chemical reactions, and you'll be taking this either on Monday or Tuesday, depending on your group. All right, so first thing I want to remind you is that the front page of your Unit 3 packet acts as a table of contents for our course. So make sure that you are familiar with the basics of chemical equations, right? Knowing what side is the reactant, what side is the product, knowing maybe a little bit about what a catalyst is and where that belongs in the chemical reaction. You're also going to want to make sure that you understand how to put together ionic compounds. We've been working on that for months. There's plenty of resources that we've had over the past several months of agendas that I'm sure you can find, or maybe I'll even post a video if I'm feeling nice for you guys. But today for this review, I'm going to focus on the different types of chemical reactions. So we will be looking at different chemical reactions, identifying them, predicting the products, writing them down into a chemical formula, and then balancing them. So I can only record videos in 15-minute segments, so it might take more than one video to go through the review that I have. But I have a good feeling that if you do spend the time to do this, put your phone away, make sure that you are focused 100% on this review, that this could be very, very helpful for you. But you need to buy in as much as I am. All right, so without further ado, you're going to want to get a piece of scratch paper out with a pencil. If you need to, you can get your blue ionic cheat sheet out. Remember, you don't have to use that on the test. If you elect not to, you get a 10% bonus on the test. And then you will also want to get out your pink predicting products cheat sheet, and you'll be able to use that on the exam, or not exam, test. So let's take a look here. The way we're going to do this is, I'm going to start here at number 2. I don't have a number 1. I deleted it. It was an acid-base problem. So you're going to hit the pause button when I tell you to, and I want you to try to answer number 2 by yourself. All right. If you need to watch me do it, that's okay. But I want you to have the chance to pause, try it for yourself, and then check your work with me. And I think that's the best way to go through this. If you're just watching me do this, it looks easy because I've done this many times, right? And I make it look easy. I'm just that good, right? But I want you guys to practice these on your own. So now's the time. Hit the pause button so you can try number 2 on your own. All right. So looking at this type of reaction, I knew this was a decomposition reaction, right? Because I only saw it had one reactant. There was nothing else left with it to react with, so it must be breaking down. And so because it's a decomposition reaction, I know I need to use my predicting products cheat sheet. And if I look all the way down, right, at my decomps, I want to decide which one is it. So I have a barium carbonate, right? Barium is a metal, so I have a metallic carbonate. So I'm going to be using decomposition reaction number 5. Right? I identified this because I knew it was a decomposition reaction. So I look on this list, and I saw the carbonate in there. Okay, so my product should be a metallic oxide plus CO2. So I should end up with, barium oxide plus CO2. So barium oxide, actually going too fast here. This is a decomposition 5 reaction, right? And my products will be barium oxide. Now barium is plus 2, as well as, right, let me double check that. Yeah, barium's plus 2, oxide's plus 2, so it's just BaO plus CO2. And if I'm looking if I need to balance this or not, well, I have one barium on both sides, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, 1, 2, 3 oxygens on the right. So we are good. So if you got this yourself, give yourself a pat on the back. If not, we're going to keep going. So pause the video, give yourself a chance to answer number 3. All right, so you should have identified reaction number 3 as a single replacement reaction. Right, so in a single replacement reaction, we want to use our activity series. Right, so that is going to be your cheat sheet that looks like this with the 2 columns. Right, so you can probably see it better a little bit right there. when I look at it, or when I'm doing a single replacement reaction, the first thing I want to do is identify my element as either a metal or a non-metal. Right here is nickel. I know nickel is a metal because it's on the left side of the staircase. Right? But if you need to confirm, you can even just look for your column on the pink sheet that nickel is located in. So because nickel's a metal, I'm going to be comparing nickel with silver, okay, and see which one's higher on the list. So when I'm looking at my list, I see that nickel is right here, and silver is down here at the bottom. Nickel is higher on the column, so that means it has a greater activity and is going to end up in the compound. So our products, right, should be nickel nitrate, right, and nickel nitrate would be NiNO3 2. If you did not understand how I made nickel nitrate NiNO3 2, you need to watch a video on how to make ionic compounds. Okay, so you need to YouTube how to write ionic compounds and watch a couple videos. All right, and then in this reaction, silver was kicked out. All right, we're not done. Right, I see that I am not balanced. So I have 2 nitrate ions on the right. I need 2 nitrate ions on the left. So I need to put a 2 there. Now that changed my amount of silvers from 1 silver to 2. So I need to correct that on the right side. In order to get full credit on this question, you need to identify it, predict the right products, put them in the right chemical formula, and then balance it. Alrighty, so that's it for number 3. Why don't you take a second to work on number 4? Right, hit the pause button. Number 4 is a combustion reaction. Okay, and when we do combustion reactions, there's no cheat sheet that we can work through. Right, we're not using this pink cheat sheet at all. Right, combustion reactions always have the same products. So in a combustion reaction, you have H2O plus CO2, and you want to leave space before them because we'll have to balance. So every single time you have a combustion reaction, these are your products, and it's your job to balance. So if I have 2 carbons on the left, I need 2 carbons on the right. If I have 2 hydrogens on the left, well, I have 2 hydrogens on the right. But this gives me 1 plus 4 oxygens for a total of 5. Right, so that 5 gets me to a 2.5 in front of the O2, but we can't do that, right? We can't have fractions or decimals in our coefficients, so our trick that we discussed in class is to multiply everything by 2. So if I multiply all my coefficients by 2, I end up with 2, 5, 2, and we're going to turn this 2 into a 4, okay? You're not going to see any tricky combustion questions like this on the test where you have to do the doubling, but you should be able to do combustion reactions with predicting the products and balancing. And hopefully we have another example as we go on. So that's number 4. Let's take a look at number 5. So you want to press the pause button, work yourself through number 5, and then hit the play button again when you're ready. So for number 5, I see I have a composition reaction. All right, so I want to turn to my predicting products cheat sheet. This is where I find, right, my answers to composition and decomposition equations. So I see I have lithium, a metal, plus bromine, a nonmetal. So when I have a metal plus a nonmetal, right, that is a composition 1 reaction, and we will produce a salt. Now, remember, a salt is just an ionic compound. It is not specifically sodium chloride, which we call table salt. Okay, so we're going to combine lithium and bromine together to make lithium bromide. So our product, right, would be putting lithium ion together with a bromine ion. So we would end up with LiBr because, right, lithium has a +1 charge, bromide has a -1 charge. They just make LiBr, but we still need to balance it, right? So if I have 2 bromines on the left, I'm going to need 2 bromines on the right. But that gives me 2 lithiums, so I must put a 2 there. If you leave this blank, you're correct. If you make that a 1, you would be correct as well. Okay, either of those is fine. All right, so that was a composition 1 reaction. Take a second. Let's try number 6. So hit the pause button. Welcome back. So right here we have an element plus a compound. An element plus a compound should tell me that I have a single replacement reaction. All right. I'm going to pause for a second. Have any of you if you have had difficulty identifying the types of reactions, right? There's a couple of things that you can do. You can look back through your notes in Unit 3 and try to identify what the keys are to identifying these types of reactions. The notes start on page 9 and they go through till page 11. So that should give you a little bit more detail about these 5 different types of reactions. There's also a little key in the back of your packet. If you look on page 47, right, there's a little key here that tells you, right, step-by-step process of how we can get to identifying our chemical reactions. So that can help, as well as there was a review quizzes on identifying different types of reactions, and I can repost that with this video as well so you can practice. So if you need to, you can pause this video, go do that stuff and come back, or you can save that stuff till later, but it is an important skill that you need to know for this test. All right, so back to number 6, we have a single replacement reaction, calcium plus hydrochloric acid, or we can treat this as hydrogen chloride. All right, so I see that my first element is calcium, which is a metal. Right? I'm using my activity series because this is a single replacement reaction, and I'm comparing calcium with hydrogen from an acid. So if I look on my sheet, I have calcium all the way up here and hydrogen in my acid all the way down here. So calcium is more active, is going to end up in my compound. So I should end up with calcium chloride, CaCl2, right, plus hydrogen, and hydrogen is diatomic, so it needs to be H2. Okay, don't worry about memorizing the diatomic elements. I will provide those to you guys on the test. But for now, just know that anything that ends in the GEN, the gens, or the INEs, the enes, is going to be diatomic. All right, so we still have to balance this. If I have 2 hydrogens, I need 2 hydrogens on the left, right, which gave me 2 chlorines, but I already had 2 chlorines, so we are nice and balanced. All righty. Looks like we have time for one more before this video will end, and we'll have to start another. So pause this video to work on number 7, right, and I'll see you in a second. All right, welcome back. So reaction type for number 7, this is a double replacement reaction. All right, so double replacement reaction means that I'm going to be using my solubility table. So my pink predicting products cheat sheet, I will be using my solubility table. And we're going to be swapping our partners. Okay, so we're going to do our outers together and our inners together to get 2 new ionic compounds. So we'll end up with silver phosphate, right, which would be Ag3PO4, plus potassium nitrate, which is just KNO3. Right, you might not be able to do these in your head. I wouldn't expect you to be able to. It might take you a little bit of time to do some scratch work on your paper, and that's more than fine. That's what I want to see you doing on your test. All right, so before we start balancing here, I'm going to identify my products as either aqueous or a solid. Okay, so I'm going to look for silver phosphate. So if I find silver all the way at the bottom, let me bring this camera up just a little bit, and phosphate right here, we should get to, right, silver phosphate is insoluble, or it should be labeled as a solid. Right? And if we did the same thing for potassium nitrate, we would see that it should be aqueous. All right. And the last thing we need to do before we're done with this double replacement reaction is balance it. So if I have 3 silvers on my product side, I need 3 silvers on my reactant side. That got me 3 nitrates on my reactant side, so I need 3 nitrate ions on my product side, right, which then gave me 3 potassiums, which balanced out my other 3